Is anybody actually here watching? I see one viewer. I'm going to try to do this so we can record it, but it's kind of hard for me to hear back from folks. So, no, okay, cool. Cool, I think there's a bit of a lag as it's buffering. So I think what I'm going to do is just go through the talk and the slides that I have. It'll take about 20 minutes. And then I can flip over to Slack and we can do some QA there. Yeah, Austin, I see. Yeah, I'm doing a Hangout on air so that I could record it. I want to try to figure out how to do this and make it work with Techlunches, although it is kind of awkward with back and forth. So I should close my window here and start up slides. Cool. So, hey, Sammy, could you do me a favor? Could you just watch in Techlunch and see if people have any problems? Because I can't see. And just like tap me on the shoulder. Cool, thanks. Okay, cool. So this is a talk I did. I'm going to run through it. I think there's some interesting little pieces of information here about how HTTP headers work in caching requests. And really the ultimate goal on this is to speed up API calls and eliminate load on our servers. It's me, you guys know that. Excuse me, agenda. So I'm going to talk about why we might need to do this and talk about some of the other caching strategies out there. We'll talk about what a conditional GET request is, and then how to implement it in Rails, and then we'll look in some of the source in Rails to get a little bit better understanding of how it's actually working. And that's it. So the problem is that we build apps really quickly, and this is a good thing. Apps consume a lot of data. That's also a good thing. And a lot of times the data doesn't change very often. So imagine an app that's, say, the list of the local baseball teams, the Giants, playing schedule, schedule for the season. That's not going to change very much. Maybe occasionally if we have an error. But caching stuff is really hard. So most of the time when we build apps, we don't cache. We just fetch all the things all the time. And that's actually fine because it leads to more simpler designs and lets us get things out the door faster. But when it comes time to scale, we're going to look and we're going to see that we're spending an awful lot of time repeatedly looking in our database, making, building up these JSON requests or HTML snippets and sending them down the wire, the same thing every time. So we're going to decide we want to cache that stuff to eliminate server load and make everything faster. And that's awesome. So we're going to Google caching in Rails, and we're going to quickly find out that the main strategy you see is what's called like fragment caching. And what that is you take a snippet of HTML or JSON, and you you render it. You calculate what it should render out to be, and then you stick that in memory somewhere, and usually in a key value store, right? So you might do this with a header or a footer, or let's say the list of Giants games for the season. You can kind of generate that list once, stick it in your memory, and then the next time you need it, instead of hitting your database, instead of making that big response, you can just go in your memory, in your cache, pull up the response and serve it right up. And there's ways and strategies to do this where you can sort of build nested structures in caching, and you can read about that. And that's an awesome approach, but you'll find that there are some challenges with it. Some of the types of caching, where you cache an entire page or you cache a whole controller action, have been kind of deprecated in Rails and moved into their own gems in Rails 4. So it's probably not the best idea. Fragment caching is still very much part of the core of Rails, but it requires extra memory. We have to pre-create these responses and stick them somewhere. You can use application memory. By default, Rails will just use its own memory, but you can also put Redis or Memcache daemon in there, and adds the memory there, but still you're still taking machine memory, right? But the biggest problem with this strategy is that it's really buggy. You have to write rules to figure out when Rails should go look in the memory for the pre-calculated response, or when it should go look in the database and update the response because some data changed. And this is really hard, actually, especially when you have nested structures. It's very difficult to write rules that all the time result in data being updated properly. It makes it more difficult because in the development environment in Rails, caching is not performed by default. So you'll be working along on your feature, maybe even forget about this caching, and then you push your code to production and users see a still data. You don't know why. You initially can't even reproduce it locally, and I've run into that, and it's really terrible. So you want to be careful when you're implementing this type of caching. Do it, but notice there's some problems. And so the point of this is that you should look at using request headers instead of, or in addition to, or maybe before looking at fragment caching. And so what I mean here is we're going to use request headers to make something called conditional requests. And this is part of the HTTP standard that allows browsers to ask if anything has changed or not. So this isn't part of Rails necessarily, right? This is just part of the way the web works, which I think is really good and really useful to know because it's applicable across lots of different type of devices and lots of different types of instances. There's some more detail on this as a helicopter is flying by our window. So much for recording. So you can, more specifically, headers can be used by both the client and the server to figure out if there's new data present. If no new data is present, the server can return a 304. And in some cases, the client can even not make a request. And we'll get into that. And so the benefits to this approach are you're not storing anything in the memory at all, right? And in some cases, you can avoid even making an API call in the first place, which is really awesome. The cache invalidation rules are a little simpler than with fragment caching. You can implement this in Rack. So if you're writing a Sinatra app, or even if you're not even writing a Rails app, the same principles apply. And you could even implement your own setup here to use these headers to cache requests. And I think that's pretty cool. And it's also just a lot faster than using fragment caching stored in memory. So how to do it. So we have an app here. This is a Pokemon's app. We have an index action. We're going to find all the Pokemons. I found the list of them. There's like 850 of them. And they all have a type. Like grass is one. I think rock. But anyway, so we do want to join here. And I kind of did this to have a more real world example. And right now we're going to set, say expires in 1 minute. And then we're going to render some JSON. So what happens when our client, there we go. The first time our users ask for our Pokemons, we're going to get a 200 response. And we're going to get this cache control max age header set to 60. Normally this is 0. And what this is saying is that the maximum age that you could possibly cache this response for is 60 seconds from now. And we're also going to say this is a private request, which means that intermediary, I don't think I'm saying that right, things can't cache it. So like an HTTP proxy would not be able to cache this request. The only person who could cache it is the end user. If we said public here, then it would be cacheable by proxies. And this expires in, takes a hash of arguments here that you can read about and tweak it and make it public and things like that. But the important thing is this times. So when we hit refresh, within 60 seconds, we get what we expect. We actually get a 304, and that's pretty cool. But something interesting is going on here. Even though we're looking at the 304 in Chrome, our server is still actually firing this code here and rendering the JSON. So we're not actually saving any server load. And interestingly, if you look at the server, it's actually returning a 200. It's Chrome that's turning this into a 304. So it's essentially ignoring this. And Chrome will actually do this past 60 seconds if it just doesn't detect a difference in the response. Under other circumstances, so let's say you take your URL here and you copy it and you paste it into a new tab and hit enter, then Chrome will figure out that the response is cached if you do it within 60 seconds, and it will not make an API call at all. So your server won't even get that call. So that's pretty cool, but the point of this time-based caching is that it's really up to the client to implement. On the server, you're just saying, hey, if you're going to cache this, you can only hold on to it for 60 seconds. It's up to the client to actually cache it and figure out what to do. Browsers have a lot of complicated rules about how and when they'll honor these things. And the rules don't include hitting refresh. So it probably isn't the most useful thing. You might use this if you were implementing, say, a JavaScript web application or a mobile client, and let's say you had a utility function and you wanted to pass everything, you're passing all your AJAX calls through one method, and you wanted to keep track of the last time you hit this endpoint, then you could conceivably do your own little calculation there to avoid making the call. Also note, in practice, you would, never do anything. See, I'm not very good at slides. You would never do anything for 60 seconds. You would do it for like a week or a month. It even says that in the docs. Cool, more interesting stuff. E-tags. This means an entity tag. And here we're doing something different. We're using the stale method. We're giving it an option e-tag, and we're passing an active record collection. And then we're using this in an if statement and wrapping our render method in that. So stale is going to return a Boolean, right? And if stale returns false, we're actually not even going to render a JSONs or a Pokemons or a JSONs. So let's look at what's going on here. Again, hit the wrong key, sorry. The first time we hit 200, we don't, the cache control header is set back to 0, but we have an e-tag set, right? And what Rails is doing is it's calculating the e-tag by attempting to find the max, the most recently updated timestamp of this collection. And you can do that in Rails by calling the .maximum method on this and passing updated as a symbol. And that's going to create some SQL that we'll see in a second that's going to find the most recently updated Pokemon, and it makes a hash. And that's what the e-tag comes out as. So when our user hits refresh, the browser is going to send the server back some request headers that include this if none match header. Rails is going to see that if none match header. It's going to recalculate the e-tag, and if they match, it's going to return false from this method. We're not going to render the Pokemons, and we're actually going to return a 304. So let's look at server logs. So this is the first time, right? The first request. You can see we're loading the Pokemons, right? And we have a 121 millisecond request. Then when we hit refresh, this is when the cool stuff starts happening. Notice we still have to hit the database to figure out that timestamp, but right after that we get a 304 and nothing else, and our response comes back in 1 millisecond. So this is really cool. See, it's pretty easy to use, and we've dramatically increased our speed. Now, there's a couple things to note. Is by default Rails 4 and up will insert e-tags for you and return 304s automatically. But unless you use the stale method, you're still going to render all of your JSON anyway, so you're not going to save any speed at all. Also, another note that I'm doing here, the database call outside the conditional, and that works because this is an active record collection association. Anyway, active record collections are lazy evaluated and won't hit the database until they're needed. So in this case, this will just get garbage collected. But probably for efficiency, I should put all of this inside the conditional so I don't even do the assignment. But that's for another day. So that's how you use e-tags. And just compare these server responses again. Pretty cool stuff. Instead of e-tags, we can use a last modified header as well to perform a similar action. Here we're going to call stale, but instead of etag, we're going to say last modified, and we're going to pass that maximum timestamp here explicitly that Rails was calling implicitly last time. And you can see the etag header is replaced by a last modified timestamp, and then our client is going to hit refresh, and they're going to send us back if modified since. Rails is going to compare these and figure out what to do for us. And finally, we can mix them up together. And this is sort of the default behavior. You see we have a really Railsy construction here. We just passed a collection in. And here we're going to get an etag and last modified timestamp. And Rails is going to compare the if not match to if modified since. It's going to compare them like that and figure out what to do. Now, the interesting thing here is you might ask, well, what if one set of these matches, but one set doesn't? In this case, that's never going to happen because the etag is simply a hash of the most recent timestamp. So in this particular implementation, those are always going to be the same because one is simply a hash of another. So we don't have to worry about this. This default method is probably the best way to go because some users will disable etags because they will can facilitate tracking online and advertising and things like that. Another thing to note here is this is a weak etag. It starts with a W, and this is because this is a Rails 5 app, and in Rails 5 went to weak etags by default. And weak etags are different than strong etags in that strong etags represent the actual response. So if any part of the response changes, a strong etag must change. A weak etag is the semantic equivalent of a response, but not necessarily the response itself. So with a weak etag, we could actually change the response. Let's say we change the format of it, but still have the same etag. And what we're saying is that these responses are semantically equivalent. We want you to treat them as the same browser. So some pretty esoteric distinction that you probably don't need to know with a little bit of trivia. This is a weak etag. If you do this in Rails 4, you'll see a slightly different construction there. So that's how you implement it. We can look a little bit under the hood about how it works. This is the stale method that we're calling. It's doing two things. It's calling this fresh when method that we'll look at, and request.fresh, and they're returning the inverse of that response. So that's how we get the Boolean response. So let's look at fresh when. There's a lot of stuff going on here. It's hard to read. The formatting's bad, but there's two basic things going on. One, we're setting some headers. Here we're setting some etag headers, strong etags, weak etags, a lot of logic to figure that out. We're also setting last modified and cache control headers. Great. The cool thing though is here is where we're calling head not modified, and this is what's giving us our 304. And this is happening if request.fresh comes back true. So this right here is what's responsible for returning that 304 for us. And notice stale is calling fresh when and request fresh. So this request fresh call is apparently happening twice. So let's look at request fresh. This is a pretty difficult piece of code to reason about because these are methods that we can't see. But the point is that this is really the core of the matter. There's a method that returns true or false, depending on whether the request should be updated or not, and it figures that out by looking at headers. Then you combine that with a method that sets some new headers for you and sets 304 response, and then you've got a nice little caching setup, and that's what we have in Rails. And that is it. I put the GitHub repo for the code that I used to build the app or build the slides is right up here. So if you want to play with this, you can clone this and actually just copy and paste from the presentation here into your controllers and kind of see how things change. So that's all. And now you can see my desktop. Cool. And are there any questions you guys want to ask in Slack? Otherwise, we can wrap it up. And I have the slides online too, if anyone wants some. I'll pause here. Cool. I don't hear any, so I'm gonna stop the hangout. Hopefully the recording was reasonable, and hope you all have a good day. Thanks for listening.